Okay, for this video, I'll be going through the revision notes for chapter 3, uh, element compounds and mixtures. Okay, so you can actually download these notes. It's actually in your Google Classroom. Now, first definition, what is an atom? So basically, atom is the simplest substance of an element, okay, which cannot be further broken down by chemical processes. So if you look at a periodic table, there are actually many elements, and the smallest thing that represents that element is an atom. Okay, so it cannot be further broken down. But some of you may have heard of subatomic particles. Okay, so these are the things that are found inside the atom. That's why it's called subatomic. So we actually have protons. Okay, so this is not tested yet, but eventually you'll need to know this concept. So we have protons, which is positive, we have electrons, negative, and we also have neutrons, which are actually neutral. Okay, so these are all found in your atom. Okay, but to represent an element fully, example, my helium atom, I can only represent it using atom. Okay, it's the smallest or the simplest substance that can represent that element. So we actually have a helium atom and neon atom. Okay, similarly, of course, we have all the other atoms, but sometimes they don't exist by atom itself, right? They actually exist as molecule. So a molecule is made of two or more atoms chemically combined together. Okay, so this example that we show here is actually the oxygen molecule. So it is a molecule because it's made out of two or more atoms chemically combined. But because it is made out of the same type of element, we call it a molecule of element. And to be more specific, it is a molecule of the oxygen element. Okay, so if I were to give another example, N and N is actually a nitrogen, and this is a molecule of nitrogen element because they are both made of the same kind of element, which is the nitrogen element. But we can have molecules that are made of two or more atoms of different element. Okay, so example, water is your H2O. So I have two H atoms and one oxygen atom chemically combined. So it is a molecule of water. So I can't call this a molecule of element because it's made up of more than one kind of element. So I should call it by a molecule of water, which is what it is known as. And later you will learn this term called compound, or you already have known. Okay. Now, what's an element? An element is a substance that cannot be broken down into simpler substances by chemical methods. Okay, so it looks quite similar from your atom definition. Please memorize both. Now, each element is represented by a symbol of one letter or two letters. Okay, the first letter is always capital letter, and the second letter is in lowercase, small letter. Now, for two letter symbols, they may not always be the first two letters of the name of the element. Okay, example, potassium. Okay, the symbol is actually K, so it may not always take the first letter. Okay. Now, classification of elements, we can classify elements by state. So we observe their physical states at room temperature. So it can either be solid, liquid, or gas. That's how we classify them. Or we can also classify them as metals and non-metals. Okay, so these are some of the properties of metals. They are shiny, high density, high melting point, good electrical conductor. Then if it's non-metal, it will just be the opposite. Opposite of shiny is dull, high density is low density, high melting point is low melting point, good and poor electrical or heat conductor. Okay, so it's a buy one get one free. Now, some other properties is metals are ductile. Okay, they are malleable and they are sonorous. So you need to get memorize what is the definition of ductile, malleable, and sonorous. Sonorous, I can recall that it makes a clear, crispy sound when it's knocked. But for non-metals like your plastic, you knock it, it won't give a clear, very crispy sound. Okay. Malleable means you can use a a mallet. Okay, so you can actually use a mallet to hit it into shape. But for non-metals, if you use a mallet to hit it, then it may break. Okay, for metals, it is malleable. You use a mallet to hit it, you can bend it into different shapes. Okay, but for non-metals, you can't. So that's why it is brittle. Ductile means can be stretched or pulled. Okay, so this is when you are pulling the metals into wires. Okay, so they can actually be stretched or pulled. But for non-metals like plastic or wood, they once you pull it, it may break. Now you need to understand or memorize some of the uses of metals and uses of non-metals. Okay, by the way, in your periodic table, in your period, it transitions from metals all the way to non-metals. Okay, so from left to right, metals to non-metals. Okay, we can classify elements according to their similar chemical properties arranged systematically in the periodic table. Okay, so this is the periodic table. It divides elements into horizontal rows called periods. Vertical columns are groups. So horizontal is from left to right. Vertical is downwards vertical. All right. So last time we used to call them the Roman numerals, but not anymore. Okay, so this is actually group 18. This is group 17. Okay, please refer to the latest copy of the periodic table. So there are actually 8 groups. Sorry, it's not 8 groups. There are 18 groups in the periodic table. What is more important is that the elements in the same group have similar properties. Okay, so if we know which group an element belongs to, we can predict its behavior. So a period is a horizontal row. In any period, the elements change from metals to non-metals, from left to right. Okay. So group 1 is the alkali metals. They are soft metals, so they can be cut easily by knife, and they react vigorously with water. So I may have shown the video whereby it's when they are thrown in water, it becomes explosive. Okay, so it must be kept under oil. So group, remember, is from top down, vertical. Then we have group 17. We call them halogen. Okay, so group 17 elements are called halogens. They are non-metal elements. They are colored substances. They are also diatomic. Diatomic means 2 atoms, like chlorine Cl2. So Cl and Cl, they form chemically a molecule. And because they are made of the same kind of element, so we can call it a molecule of the chlorine element. Okay, it is not a compound because it's still made of the same type of element. So we have chlorine, we have bromine and iodine. Then we have the group 18, which is the noble gases. They are called noble gases. They are inert, they are unreactive, right? They do not take part in any chemical reactions. They have single atoms. So they can exist as single atoms like helium, neon, okay? Something that the other groups, elements, they can't. So what is a compound? You need to memorize this. It's a substance consisting of 2 or more different elements. So this is the key concept, and they must be chemically combined. Now, a chemical formula is used to describe the number and type of elements that form or constitute a compound. So H2O, we covered that. How many elements are there? There are actually 2 elements, H and O. And how many types of H? We have 2. You can actually count. The number that comes after the letter belongs to the letter before it. Okay, so I have 2H and 1O. Now, compounds are formed during chemical reactions where heat and sometimes light energy or electrical energy is given out or taken in. So the formation of compound firstly can be through the chemical combination of elements. So I take 2 different elements, I combine them. So example, this is the word equation for magnesium and oxygen. So those on the left hand side will be the reactants. Okay, then the magnesium oxide will be the product. Okay, and because now this is a molecule of the magnesium oxide and it is formed by 2 different elements, then it forms a compound, no longer a molecule of element. So we can also have elements and compounds chemically combined. So we have nitrogen oxide because it's again made out of nitrogen and oxygen, so it becomes a compound already. We can react it with more oxygen and it forms nitrogen dioxide. Okay, so it is my NO2. Now I have dioxide, I have 2 oxygen. Or we can actually have chemical combination of compounds. That means compounds and compounds react. So ammonia is NH3. Okay, sooner or later you'll learn this. NH3 is made out of nitrogen and hydrogen. 1 nitrogen, 3 hydrogen. It can react with hydrogen chloride, which is our HCl. So made out of hydrogen and chlorine. So they can actually form ammonium chloride, which is NH4Cl. Okay, so we can have compound and compound react together to form compound. Now, what's mixture is made out of 2 or more substances not chemically combined. So just now we have covered compounds which are all chemically combined. So mixtures are not chemically combined. It may consist of elements, compounds, or both because it's a mixture. It may be made up by solid, liquids, or gases. Okay, so example, some of this you need to know. Okay, compound versus mixture, characteristics of compound. So you may want to memorize this. Compounds are formed by chemical reactions which usually involve an exchange of energy with the surrounding. But for mixtures, no exchange of energy. So it is a direct comparison. So you can just memorize one side and then you apply the opposite to the other thing that you're talking about. Okay, you can either memorize compound, then you apply the opposite to mixture. So very important, a compound has properties that are different from the properties of its constituent elements. Okay, so example, your sodium chloride. Sodium is metal. Chlorine is actually a non-metal and it's actually a poisonous gas. And together they can combine chemically to form a sodium chloride, which is our table salt. Okay, which you can eat. But if I were to ask you to take in chlorine gas, it is toxic. Alright, so the compound that is formed will actually have properties different from the constituent elements. But the mixture will have the properties of its constituent substance. Okay, so basically apply the opposite to it. Now, compound, since it can be formed by chemical processes, it can also only be broken down into simpler substances by chemical methods. But for mixture, they can be separated by physical methods, which is chapter 4, which you'll be learning. Now, different elements in a compound are chemically combined in a fixed proportion by mass. That means if I'm talking about compound of water, H2O, it will always be 2H and 1O. Okay, so it is fixed proportion. Now, for mixtures, they can be mixed in any proportion by mass. Okay.